Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.10 entitled Lines. And we have a lot of objectives to get to today. We're going to talk about the slope of a line. We're going to talk about point slope form, slope intercept form, and also standard form for the equation of a line. We're going to review horizontal and vertical lines, the general equation, that's the standard form for the equation of a line. We're going to talk about parallel and perpendicular lines, and then also modeling. So that means we get a word problem at the end that deals with slope. Okay, so remember, slope of a line is basically the ratio of the rise of the line over the run of the line. And we have these awesome pictures here that are a little funny. If you have a positive slope, then it's like you're going up, you're climbing the mountain. If you have a negative slope, then you're going down. It's like you're skiing down the slope. And we have an equation that helps us do that, so we don't have to sit there and count on the graph every single time. So the rise is basically the change in the x-coordinates, and then the run is the change in the rise is the change in the y-coordinates, the run is the change in the x-coordinates. And the ones and twos, again, they don't really necessarily mean anything other than that there's order. Order is important here. So it doesn't matter which ordered pair you call x1, y1, and x2, y2, but it does matter the order that you subtract them. So if you subtract y2 minus y1, you have to do x2 minus x1. And basically, you can find the slope by counting or making triangles. So you're dealing with your rise over your run. So this is just an explanation to show how you're calculating the change in the y values and the change in the x values. So let's practice it. Let's find the slope. We're going to find the slope of the line that passes through the points P and Q. And P is 2, 1, and Q is 8, 5. So we're going to use our equation. M equals y2 minus y1 over x2 minus x1. Again, it doesn't matter which ordered pair you call x1, y1, and which one you call x2, y2. If you need to label them, label them. That's totally fine. There's no shame in that. So if I call q my x2, y2, then I'm going to take my value for y2 and subtract it from the value for y1 in p. So 5 minus 1. And then my x's, let's see, I'll have 8 minus 2. And then I got to simplify those. 4 over 6 and reduce that. My slope is 2/3. Remember, we always want to reduce our fractions, even when it's slope. Now we're also going to talk about point slope form. And this is a very user-friendly equation for a line. It deals with a point and the slope. So if you know a point and you know the slope, you basically just plug them into this equation. Now the y and the x that are just x and y are going to stay x and y. The y1 and the x1, that's going to be your x and y coordinate in your ordered pair. And then of course we have our slope too. And you can just substitute those values in, and then you can basically turn that form of the equation into either slope-intercept form or standard form. So we're going to practice this by finding the equation of a line that goes through 1, -3, and has a slope of -1/2. Now they have a picture here to help you visualize it, but again, you don't really need the picture. We're going to use our equation. So y minus y1 equals m times x minus x1. Now the minuses stay in the equation. So if we're plugging in a negative number, it's going to be minus a negative. So this will be x1, y1 for my ordered pair. So I'm going to have y minus a -3, so that's going to be +3. My slope is in the -1/2. And I'm going to have x minus 1. Now, technically, we could leave that. That is the equation of a line, but we want a little more user-friendly one that we're more familiar with. So I'm going to substitute, or not substitute, distribute that -1/2 and then I'll solve for y. I'll subtract the 3 over to the other side. So then I'll have y equals negative 1/2 x, and then 3 is actually 6/2, so 1/2 minus 6/2 would be negative 5/2. So that would be the equation of my line. And you can see in the picture, negative 5/2 is negative 2.5, so we're starting at our y-intercept of negative 2.5, and then we're going down 1 and over 2. Okay. All right, slope-intercept form, that's the form of the equation that we just had. And this is a reminder that if we take that slope and our point and substitute them into the point-slope form, we basically get this equation, y equals mx plus b. Remember, m is going to be your slope. I don't know why they use the variable for m for slope. Old dead math people decided on that. It probably has some sort of Latin root to it. And remember that b is actually the ordered pair 0b. That's your y-intercept. The intercept is actually a point. Sometimes students tend to overlook that it's 0 and then that number because you're on the y-axis. And in order to be on the y-axis, you have to have an ordered pair that's 0 and then a number. Okay, so example 4 has 2 parts. It says find the equation of the line with a slope of 3 and a y-intercept of negative 2. So this is very, very basic. Y equals mx plus b. They give me my slope and they give me my intercept, so I know I'm using slope-intercept form. I can just substitute them in. My slope is 3 and my intercept is 2. So y equals 3x minus 2. So don't let those easy, straightforward problems trip you up on the homework. Example B has a little more work to it. It says find the slope and the y-intercept of the line. And now they give you the equation of the line. And this form is the standard form, which we'll talk about in a moment. But if I want to find the slope and the y-intercept, the best way to do that is to solve the equation for y. If I solve for y, it's going to be in the y equals mx plus b form. So I can just look at the equation and find my slope and find my intercept. So to solve for y, I'm going to have to add the 2x over. And I want the x term to come first because it comes first in my slope-intercept form. And then I have to divide by 3. So 2/3 x plus 1/3. So my slope is going to be 2/3. And my y-intercept, don't just put down the number for b. Remember, it's an ordered pair. It's going to be 0, 1/3. So really, really try to think of it as an ordered pair for that intercept. Write down 0 and then the number for b. That's what good mathematicians do. Okay, a little refresher on vertical and horizontal lines. Remember, vertical lines are always going to have the equation x equals something. X equals some number. So a vertical line, if you graph it, if it was x equals 5, you'd go to 1, 2, 3, 4, 5 on the x-axis, and you draw your vertical line through the x-axis. A horizontal line is going to be y equals some number. And again, if you had y equals negative 3, you'd go to negative 3 on the y-axis and you draw a line across that axis. Remember, vertical lines have a slope that is undefined because their slope is really the number over 0, and you can't divide by 0. The vertical lines rise, but they don't run. So a number over 0, that's undefined. Horizontal lines have a slope of 0 because they do not rise at all, but they do run. So their slope is actually 0 over a number. 0 over any number is just 0. So I'm not going to do an example for horizontal and vertical lines. You might see that in your homework though. So now we're going to talk about the general form or the standard form for the equation of the line. Your book calls it general form. I like standard form. And the book also presents it this way, ax plus by plus c equals 0. You might know it as ax plus by equals c. That's the standard form that you get taught freshman, sophomore, junior year. So here we have an equation that's in standard form, and they want us to graph it. So we have 2x minus 3y minus 12 equals 0. And, excuse me, there's two ways that you could do this problem. You could solve the equation for y, put it in slope-intercept form, find your slope, find your intercept, and then graph. The other way to do this would be to find your x-intercept and your y-intercept. So I'll do both. If we're going to solve for y, I'd have to subtract the 2x over and add the 12 over. So I'd have negative 3y equals negative 2x plus 12. And then I'd have to divide everything by negative 3. So y equals, give me a positive 2/3 x, and then a minus 4 when I divide by that negative 3. So that's the equation of the line in just a different form. That's my slope-intercept form. So the nice thing about these equations is that they convert back and forth from one another. You can start with point slope and write it in standard, and then write it in slope-intercept. They're all connected. So my slope is 2/3, and my y-intercept, it's not just negative 4. Remember, it's 0, negative 4. So then if I was going to graph this, I'd have to draw in my axes, my y-axis and my x-axis. And I'd want to go to negative 4 on the y-axis, and then I want to rise 2 and go over 3. Rise 2 and go over 3. And you generally need 3 points to make a line. So once you have those 3 points, you can just connect them, and there's your line. Now, I know I said that you need 3 points to make a line, but if you find your x-intercept and your y-intercept and graph, you really only need 2 points to graph your line. And remember, to find your x-intercept, you plug 0 in for y, and you solve for x. So I would have 2x. I'm plugging 0 in for y. This whole minus 3y term is going to go away. So that becomes minus 12 equals 0. So 2x equals 12, so x is 6. So my x-intercept is going to be 6, 0. 1, 2, 3, 4. 1, 2, 3, 4. Oh no, I messed up on my graph a little bit when I was drawing it before. All right, let's see if I can erase that, fix that. Okay, found the eraser, so let's adjust that just a bit. Okay, so let's see, I had my axes in there. Okay, so I started at negative 4, 1, 2, 3, 4, and then I went up to and over 3, up to and over 1, 2, 3. There we go. I went over 2 before. Okay, so now I have my line. Okay, so now my x-intercept is 6, 0, so 1, 2, 3, 4, 5, 6. There we go. Now it's the same point that I had before. And my y-intercept, remember, if I'm finding my y-intercept, I want to substitute 0 in for x and then solve for y. So if I substitute 0 in for the x, that whole 2x term goes away. I still have the negative in front of the 3y though. And then I'm going to add the 12 over and divide, so I get a negative 4. So my y-intercept is going to be 0, negative 4. So 1, 2, 3, 4. There you go. So those are the same 2 points that I have on my x and y axis from graphing with the slope-intercept form. So I would just plot each of those points and then just connect them. I wouldn't have that point in the middle if I used my y-intercept and my x-intercept method. Okay, parallel and perpendicular lines. Remember, parallel lines have to have the same slope. That's what makes them parallel. That's what makes them not touch. So for example 7, we're going to find the equation of the line that goes through this point and is parallel to that line. Now really when problems are written like this, sometimes they intimidate students. It's really just kind of a little riddle. We know that we want them to be parallel, and it's got to be parallel to this line. Now, if that line wasn't in standard form, it's in standard form right now. If it wasn't in standard form, if it was in a different form, it would be really easy to tell what the slope of that line was. Because that's the same slope I need for my line. If I want the two lines to be parallel, they have to have the same slope. So I'm going to start by rewriting the equation in slope-intercept form. So I'm going to solve for y. So I'll have my 6y, and then I'll subtract the 4x over and subtract the 5 over. And then I'm going to divide everything by 6. So I'm going to get negative 2/3 x minus 5/6. Now, I don't really care about the 5/6. It doesn't bother me at all. What I'm focused on is the negative 2/3 right there. That is my slope. That's the slope that I need. And I want to use that exact same slope in my new equation for my new line because I want them to be parallel to each other, and parallel lines have the same slope. So now the second step of this equation then is to write an equation of a line with this point and this slope. So I have a point and a slope. So I'm going to use point-slope form. That is the y minus y1 equals m times x minus x1 form. So y minus 2, my slope is negative 2/3, and x minus 5. And then I could leave my answer like that. That is an acceptable form for the equation of a line, but it's not super duper user friendly. So I'm going to go ahead and distribute negative 2/3 x. And remember, when you multiply a fraction by a number, you multiply across. So I'm going to have plus 10 over 3. And then I'm going to add the 2 over to the other side. So I'll have y equals negative 2/3 x. Now 2, remember, is 6/3. So I have 10/3 plus 6/3. So that's 16/3. There's the equation of my line that is parallel to the line that I was given. If I wanted to check it, I could graph them. I could plug this slope-intercept form version of the given equation into my calculator and this one that I have and plug them into my graphing calculator, and I would see that they are parallel. As you know, looking at the equations, though, that they have the same slope, so they're parallel. They have different intersects, so I'm not going to, they're not going to touch, they're not going to be the same line. Okay? So those would definitely be parallel. Okay, perpendicular lines have opposite reciprocal slopes. Your book calls them negative reciprocal slopes. That's how you get that right angle to form. So if one line has a slope of 2/3, then a line that's perpendicular to it has to have a slope of negative 3/2. So you need the reciprocal, and if it's positive, you got to make it negative, or if it's negative, you got to make it positive. So example 8, we have this one and then one more. Example 8 says to show that the points P, Q, and R are the vertices of a right triangle. Now, the nice thing for us is that they gave us a picture that goes along with this problem. If this was just the way that the problem was written in your homework, you would want to graph the points first to see the triangle. And in our diagram, we can see that R is our right angle. So if I'm trying to show that this really is the vertices of a right triangle, I need this side here, the QR, and this side here, PR. I need them to be perpendicular because perpendicular lines form that right angle. So if I can find the slope of QR and the slope of PR and show that they are opposite reciprocal slopes, then I will know that the lines are perpendicular and that they are the vertices of a right triangle. So this is just basically reviewing slope. I need the slope of the line QR. Okay. So that's going to be, let's see, y2 minus y1. And again, it doesn't matter which coordinate you use for x1, y1, and x2, y2. So I'm going to take my y values and subtract them. And then I'm going to go in the same order. I'm going to take my x values and subtract them. So 8 minus 11. So that's going to be 12 over negative 3. So that slope is negative 4. Now the opposite reciprocal of that is 1/4. So if I get 1/4 for my slope of PR, then we will be in business. We will definitely have a right triangle. So P and R, again, doesn't matter which one I call x1, y1 or x2, y2. I'm going to subtract my y values. So let's do 5 minus 3, and then subtract my x values, 11 minus 3. So I'm going to, in a different order this time from what I did in the first one, the first slope. But again, doesn't matter as long as the order is the same for the x's and the y's. And doing it this way this time keeps my values positive. And look at that, when I reduce 2 over 8, I do get 1 over 4. So since I have opposite reciprocal slopes, that means that I have perpendicular lines. So I am definitely going to have a right triangle. Remember the directions said show, so you want to show all this work. Okay, last problem then is a word problem. And it talks about rate of change. Rate of change is a fancy schmancy phrase that means the same thing as slope. It's basically what slope is. It's how fast or how slow something is changing. And we have an example here of a gas tank that's being filled, and it takes 3 minutes to fill it up with 6 gallons of gas. So that means that its slope is 3 gallons for every 3, or 6 gallons for every 3 minutes. So that's 2 gallons per 1 minute. And then you could reverse it as well. If once you start driving your car around, the tank of gas is going to get drained. And they calculated that it drains at a rate of 0.03 gallons per minute. So you're going to go down and over. So here they have whole numbers. Okay, this is 0.03 hundredths. Okay, 3 hundredths. So you would go down 3 for every 100, down 3 gallons for every 100 minutes. So for our example, we're going to have an equation and we're going to have to interpret it and graph it. Now in your homework, they might give you a graph that they want you to interpret, or they might give you an equation that they want you to graph. Okay, so here we have a situation where we have a dam that's been built on a river and it creates a reservoir. And the water level is W, and it is represented by this equation. W equals 4.5t plus 28. And t is the number of years, so t is time since the dam was built. And W, again, the water level, is measured in feet. So we're going to sketch a graph of this equation, but first I want to do part B. Part B says, what does the slope and the intercept of this graph represent? And notice that we don't have y equals mx plus b, even though it is in slope-intercept form. It's in that form. But since it's not y equals, we don't have a y-intercept. We have a w-intercept since it's a w equals. Very clever. Okay. But regardless of what the variables are, the slope is still going to be the number that in this case is in front of the t, and the intercept is going to be the number that's added or subtracted on at the end. So what does that intercept represent? Okay. Well, the y-intercept, or the w-intercept actually, is going to be 28. Okay. W-intercept. Okay. That's 28. And that is how much water, or how many feet of water are already in the reservoir. I'm going to abbreviate that. So that's your starting level. You have 28 feet of water in the reservoir. Okay. And then your slope was 4.5. And that means that you get 4.5 feet of rain per year. Since it was measured in feet and T was in time, which was years, it's feet per year, feet of rain per year. Now it's good to know what that stuff is before you just start willy-nilly graphing, okay? So now that we know what it is, now we're going to go back and we're actually going to make our graph. So when you make your graph, there's a couple different ways that you could do it. You could use your slope and you could use your intercept. And you could make your axes here. We'd have our y-axis and our x-axis. We'd have years going across the bottom. So let's give ourselves a little bit of space here. Do every other. So we have 1, 2, 3, 4. So those will be our years. You want to label everything. And then going up on the y-axis, let's do every other. Let's do 10, 20, 30, 40, 50. Okay, 10, 20, 30, 40, and 50. And that'll be the feet, or the water level, I guess, water level, water in feet. Okay. So you could start at 28, and my line for 30 is a little bit off. It should be right about there. So you could start at 28, and then your slope is 4.5. If we change that from a decimal into a fraction, that would be a slope of 9/2. And your intercept is going to be 0.28. Now that might be a little challenging to graph in this format, starting at 28 and then going up 9/2, up 9/2. That might be a little challenging to do. You could do it for some problems, but this one, that's not so user-friendly. So the other method that I would do that's a little more useful is make a table. Make a table of values. If time is 0, then your water level was 28. After, you could plug in 1, or after 2 years, your water level would be at 37 feet. After 3 or after 4 years, your water level is 46. So plug the equation into your calculator and it'll spit out the table of values for you. Okay, I can even show you that. Go to y equals, type in 4.5 x plus 28. We have to use x because we don't have a t in our calculator. Don't use the alphabet letter t. Use that x, t, theta button that represents the variable. And then just go to second graph so you get your table of values. Now we don't want negative values because that doesn't make any sense. Oops, because we're not dealing with negative time. We're not going back in time. 0 is 28. Oh, that's why I skipped 1, because it's 32.5. Now that's not a bad value to graph. Okay, you can graph halves on your graph. But 2 is 37, 4 is 46, 6 is 55. Okay, so it doesn't say how big to make the graph or for how many years you need to graph it, but let your calculator do the work for you. We spent a whole day on how to use your calculator, so go to your calculator and have it make the table of values for you. And then you can plot those points. 0.28 would be right about there maybe. 2.37, so at year 2 we're at 37, so that might be right about there. Year 4 we're at 46, so there's 45, 46, right about there. So there you go. There's your graph. Now it's a linear graph. It has the same slope, so it's going to be a straight line. So if you wanted to, you could continue this out and put an arrow at the end of it. But, you know, that is personal preference, I guess. Okay, so there's your homework for this evening so that you can practice these concepts. Some of these problems can be a little tricky, especially with the parallel and the perpendicular and having to do multiple steps and use different forms of the equations. So if you have any questions, come on in and see me before school.